we're going to finish up the 5-4 notes. So, we are solving radical equations. As a reminder, to solve radical equations, first things first, we want to isolate the radical. Once we isolate the radical, step 2, raise both sides to the power of the index. And step 3 is solve the remaining equation. Solve the remaining equation. All right, so we got two problems on this slide. Problem A, Elvis, is the radical isolated in problem A?
Yeah.
Yes. There's no number in front multiplying. There's no number behind it adding or subtracting, so the radical is isolated. What is the index for a square root? 2. So we're going to square both sides, or raise both sides to the power of 2. Right? A square root and a square will cancel each other out. So to clean this up, we have x squared equals 7x minus 8. And now we have to solve the remaining equation. What type of equation are we dealing with now? Quadratic. Right. So when it comes to quadratics, we want to get the whole thing set equal to 0. So we're going to subtract 7x and add 8. We're going to subtract 7x and add 8. So we get x squared minus 7x plus 8 equals 0. After we get it set equal to 0, we want to try and factor if we can. So do we have any factors of 8 that add up to negative 7? What are they? 1 plus 8 is 9.
Oh. Negative 8 and 1.
No, that's negative 9.
Oh, you guys? Chat, what happened? Uh-oh. Biscuits. Mr. Stevens made a big time boo-boo. The original was 7x plus 8, right? So that should have been 7x plus 8. And instead of adding 8 to both sides, we needed to subtract 8 from both sides. Huh. I was being a silly goose. That makes this dramatically easier.
Negative 8 and 1.
The negative 8 and a positive, right? So we have x minus 8 and x plus 1 equals 0. Set each factor equal to 0 and solve, so we get x equals
8 and negative 1.
a positive 8 and a negative 1. Really, really good. All right, so plug these back in here and see if they work. So if I plug a negative 1 in, I would get negative 1 equals the square root of 7 times negative 1 plus 8. So negative 7 plus 8 is 1, so negative 1 equals the square root of 1. Is that true? No. Again, we're only looking for the principal root, so that does not work, meaning this guy is extraneous. All right, now we got to check 8. So is 8 equal to the square root of 7 times 8 plus 8? Well, I have no idea what 7 times 8 is.
Well, it's 56.
56, good. 56 plus 8 is 64. So is the square root of 64 the same thing as 8?
Yes.
Yeah, so that checks out. So that solution is good. The negative 1 is extra, a little extraneous. Okie dokie, Smokey. Ooh. I'm going to use my brain real quick. Use my brain. Negative 1 is the only value that's going to work here. Well, the only number, the square root is the same as the number. There's only one of those, right? 1, the square root of 1 is 1, right? So x plus 2 has to equal 1, meaning x has to equal negative 1. Watch. Trust the process on this one. Is the radical isolated?
Yeah.
Yeah, so I have to square both sides. Squared. Squared. So the right-hand side becomes x plus 2. The left-hand side Oh, those are calc notes. Who needs calc notes? Let's take a look. 2 years from now, you will. X plus 2. Here. All right, we go to FOIL it out. We get x squared plus 2x plus 2x plus 4, which gives us a grand total of x squared plus 4x plus 4. That is our left-hand side. So going back to my equation here, I have x squared plus 4x plus 4 equals x plus 2. Got a quadratic, got to get it set equal to 0, so subtract the x and the 2, subtract the x and the 2, so we get x squared plus 3x plus 2 equals 0. Oh, I guess there is another number that works. Factoring this, we get x plus 1 and x plus 2 equals 0. So x equals -2 and -1. So -2 plus 2 is 0. -2 plus 2 is 0. Is 0 the same thing as the square root of 0?
Yeah.
Yeah, so -2 works. -1. -1 plus 2 is?
Or -1.
-1 plus 2 is? 1. Is the square root of 1 the same thing as 1? Yeah, so both of these solutions actually work. Huh. That's exciting.
Okay.
Okay? All right. So that was part of the last problem. Okay, keep cruising. Oh, rational exponents. I'm not making you do that. I'm not going to make you do that. This problem, I'm not going to make you do. But if you had to do this problem, raised to the reciprocal power. So you want the reciprocal power. This is a 5/2, so we would raise to the 2/5. Okay? So you raise to the reciprocal power. But I'm not making you do those. Thank you, Mr. Stevens. That was really handsome. I know. I know. So we could skip this problem and these problems. You're welcome.
We're on a roll.
We are. You want to know some really, really good news? I also took these out of your homework.
I was very
You're
handsome
right.
of you.
Yeah, but we're going to do this one problem. We're going to do this one because I want you to see it, even though it's not going to be part of your homework. All right, so what happens when I have two radical equations? When I have two radical equations, I want to isolate one radical first. So I'm going to isolate the square root of x plus 9, and I do that by adding the square root of 2x to the other side. So the square root of x plus 9 is equal to 3 plus the square root of 2. So there's two radicals. We're going to solve this by isolating one of the radicals and getting rid of it. And then we're going to still have another radical involved, and we're going to have to go isolate that guy and get rid of it.
We'll give you the square root of 2x.
Yes, it is. It's 2x. Thank you. Thank you, thank you, thank you. All right, so if I square both sides, I get x plus 9. Now 3 plus root 2x squared. Ugh. So that's 3 plus root 2x times 3 plus root 2x. I like to have scratch paper so I can mess up if I need to. So foiling this out, 3 times 3 is 9. 3 times root 2x is a positive 3 root 2x. Root 2x times 3 is a positive 3 root 2x. What's root 2x times root 2x going to get us? Yeah, good. All right, the square root of something squared is just the something. And now we can clean this up a little bit. We have 9 plus, that's how many root 2x's? 6, right? 3 root 2x plus 3 more root 2x's is a grand total of 6 root 2x's. All that plus 2x. All right, so that's the right-hand side of our equation. Here we are. x plus 9 equals 9 plus 6 root 2x plus 2x. Alright, so now with this equation, we want to isolate the radical again. So I have to isolate this radical right here. So we're going to subtract the 9. I'm going to subtract 2x. So that leaves me with a negative x equals 6 times the square root of 2x. Yeah, now we divide by 6. Good. So that's negative x over 6 equals the square root of 2x. Now we square it. Good. That side squared, that side squared. Negative x times a negative x is a positive x squared. 6 squared is 36. On the right hand side we have 2x. Now, in this situation, I want to get rid of the denominator. So what can I do to both sides to get rid of that 36? Multiply by 36, yeah. Right, and the left, those would cancel out, and it would give us x squared equals 72x. It's a quadratic, so we want to get it equal to 0. Subtract 72x. So x squared minus 72x equals 0. And now we factor. What do both of them have in common? X. Good. What's left over? Yeah, good. X minus 72. Nice. Set each factor equal to 0 and solve. So x equals 0. I'm going to solve that. Okay, I'm done. And x minus 72 equals 0. Add 72 to both sides, so x would equal 72 as well. So 0 and 72. To plug that back in to see if it works. Biscuits. Well, the beauty is 0 plus 9 is 9. The square root of, well, let's go back here. Let's go to the very original. All right, checking 0. All right, 0 plus 9 is 9. 0 times 2 is 0. So that root 2x goes away, and the square root of 9 is 3. So 0 works for sure. 72 plus 9 is 81. Hey, that's friendly. What's 72 times 2?
144.
Yeah. Absolutely. So we have the square root of 81 minus the square root of 144. Is that the same thing? It's 3. Does 9 minus 12 equal 3? No. Negative 3 does not equal 3. So 72 we would say is
Evil.
close.
Extraneous.
Extraneous. All right, that's it. The rest of the hour is yours to do your homework.